So here's the formula for the standard equation of an ellipse centered at HK with major axis along the x-axis. We're assuming A is greater than B. And here's a graph of the ellipse. C and the when we're dealing with ellipses represents the coordinates of the foci. So because the vertices are at 8, 0 and negative 8, 0, the center of the ellipse has to be halfway between them. So the center of the origin, or the center of the ellipse is at 0, 0, or the origin. So that means we're down to x squared over a squared plus y squared over b squared equals 1. And we know that a is 8, the distance from the center to one of the vertices. So we got x squared over 64. The only question at this point is, what is the value of b, which is this distance right here? And we can get that from this formula over here. So c is the distance from the center of the ellipse to the foci. So the square root of 20 squared is 20. A squared is 64. Solve that for b, or b squared. B squared equals 44. That's really all you need to know. B is actually the square root of 44, but here's your equation right here. And if we go to Desmos, and I actually type in x squared over 64 plus y squared over 44 equals 1. We get the same ellipse that I had pictured in the diagram because I let a equal 8 for our general formula, b equal the square root of 44, and the center h equals 0, k equals 0. And by the way, the sum of these distances right here, the distance from a point on the ellipse to each foci, remains constant. That's the definition of the points on an ellipse. And as I move this point around the ellipse, you can see down here that this d remains constant. So let me see if I can keep that. Yeah. Focus on the d. It just remains 16 no matter where the point on the ellipse is. Okay. So there you go. Hope that helped. I'll stop sharing. If you have any questions, post a comment. There you go.